And thanks for joining our panel today, the year of the massive IoT revolution. My name is Ryan Chacon. I'm one of the co-creators and podcast hosts at IoT for All, and I'll be your moderator today. But before we start, let's get into knowing a little bit more about our panelists. First off, we have Henrik Dahlgren, the head of IoT ecosystem and partnerships at Ericsson. Henrik is responsible for building a compelling ecosystem of partners that make cellular connectivity easy to choose, easy to use, and easy to scale. Hi, Henrik. Thanks for being here today.
Thanks, Ryan. Appreciate you having me on.
Yeah, it's great to have you. All right, second, we have Dennis Kish, the Chief Operating Officer at CalGlass. CalGlass, for those of you who are unfamiliar, is a leading enabler of digital transformation using IoT. From end-to-end IoT solutions to components that combine high-performance RF design with advanced positioning, imaging, audio, and artificial intelligence technologies for organizations solving critical problems. Thanks for joining, Dennis.
Thank you, Ryan. It's great to be here.
Yeah, we're very excited about this. Next up, we have Jeff Clemo, the Vice President of Strategic Channel Sales at Telit. Telit is a global leader in IoT enablement with an extensive portfolio of wireless connectivity modules, software platforms, and global IoT connectivity services. Glad to have you here, Jeff.
Thank you, Ryan. Looking forward to it.
Absolutely. And lastly, we have Andrew Reiter, the Product Manager at Digi. Digi has been a pioneer in wireless connectivity and communications since 1985, and today their IoT offering includes a diverse portfolio of wireless technology ranging from embedded modems and routers to sophisticated management platform, as well as professional design, implementation, and certification teams to help you carry out your vision. Hi, Andrew.
Hi, Ryan.
Great to have you. All right, so let's dive right in. The transition from simple machine-to-machine connections to the complexity of IoT is very well underway. The industry now recognizes that IoT projects will fall into one of two categories: critical IoT and massive IoT. Massive IoT deployments can include anywhere from hundreds to billions of connected devices, with the primary goal of these applications to efficiently transmit and consume small amounts of data from vast numbers of devices. For example, with connected cars, wearables, homes, cities, and industrial IoT. Now, while the demand for critical IoT applications will remain high, industry experts view 2020 and 2021 as the banner year for massive IoT. And today, our focus will be to discuss the challenges of massive IoT, and we will share best practices of accelerating deployment of massive IoT applications and services. And with that, Henrik, I'd like to pass it over to you.
Thank you, Ryan. I appreciate it. As always, IoT is everything and nothing, right? We've got to start with the enterprise challenge because there's a huge difference if you're a utility company connecting smart meters or if you're a home alarm company or an automotive company, right? But everyone have different challenges. And one of the things that we see is that it's a hard time to get the whole stack of cost together for an enterprise, understanding what's the cost to build or buy a component that they can connect, what's the cost of connectivity, what's the cost of the application, and how do we monetize that value. In order to do so, they need to connect virtually dispersed systems to kind of get it all together, and they need help from the ecosystem. In IoT, there's no such thing as a one-to-one competitor. There's room for everyone. We just got to help out and make sure that all the enterprises get access to the right technology and the right experts to build the solutions they need. But it's also a challenge. If you are a pump company and you build really good water pumps, over time, if you connect your assets and you want to monitor them 24/7, you got to change your operational setup. That's a huge challenge for the enterprises today, and how they interact with these pumps and what they do with the data. And then once you have all the data, deriving it to insights and getting value out of those insights in order to take actions. All these enterprise challenges are really hard to address, and there's never a silver bullet in IT. Anyone who says I have the thing that will fix it, please introduce me to him. I would like to see him. So we in Ericsson, we help the mobile operators of the world to address the IoT market through enterprises by engaging with them on helping them with IoT application platforms and connectivity management platforms, and also dedicated networks. Because it's clear that there's no one solution that fits all. In some aspects, we will need a dedicated network. In some, the macro network will be good, and in some, there's no room for the cellular. It will be a Bluetooth to a gateway that will be cellular connected. And we help over 6,000 enterprises in over 100 countries, connecting items, collecting data, driving insights. And if it's one thing I've learned is that we need to collaborate better, be more open to collaborate across geographical boundaries, company boundaries, in order to address the true pain points of the enterprises. And whenever we have success, communicate it and replicate it for scale. And if there's one thing I've learned in these 8 years in this industry, it's that everything can be connected. Every point of data can be collected and drawn a new insight from. There's no such thing as this is unnecessary to connect to. Yeah, and that's what I wanted to say. And back to you, Ryan.
Thanks, Henrik. That was great. All right, so next up, we're going to hear from Dennis Kish. Please feel free to take it away, Dennis.
Thank you, Ryan. Allow me to start by introducing Tauglass and telling you a bit about where we fit into the ecosystem today. So Tauglass is an enabler of digital transformation focused on IoT. We are longstanding experts in RF and cellular technologies, and more recently have begun to bring entire IoT programs to market with enterprise customers. We have been in the business now for 16 years and have been focused on IoT for nearly all of that time, and to even the predecessor market, machine to machine, before it was called IoT. And we have experience now with tens of thousands of projects over that time. And in the last couple of years, we have decided to move up the value chain and start providing more end-to-end solutions. So we're covering areas from strategy of the IoT solution through design and manufacturing, deployment, and even managed services. And we're doing that in partnership with many other ecosystem players who are in the market, including the folks who are on this webinar with us today. So we have built up a reputation over those years of high quality and reliability in our solutions, and become a trusted advisor to customers who are on this IoT journey with us. We have seen an interesting number of applications start to emerge with a massive IoT sort of flavor to them. So we pictured a number of those on this slide here today. Beginning on the far left with smart cities, we're starting to see now that smart metering and smart lighting are driving momentum in this market, primarily because they save cost. So the deployment can result in lower bills for the folks who are deploying them. And that creates an opportunity for people to add more capabilities as the technologies are being rolled out. In addition to that, we've seen that the worldwide pandemic that we're all suffering through together now has actually created a new need for crowd management and for contact tracing. This is for both cities and businesses. And the locationing and proximity solutions that underlie those sorts of products and offerings are here to stay in our estimation. We see that there are many uses for them in retail or in real estate or in advertising. If we go on to connected health, we've seen there monumental changes in this market. It's already sizable at $72 billion in 2020 and is forecast to grow to nearly $200 billion by 2025. Within our own customer base, we've seen a rise of patient monitoring, portable oxygen units, CPAP machines, defibrillators, and as you see pictured in the top photo here, home medication management solutions. This is an actual example of a project that we did with Health Beacon that allows you to manage medication dispensing to consumers who are around the world. The next vertical that we're showing there is smart agriculture. That's a bit smaller now at around $5.5 billion, but is expected to triple to over $15 billion by 2025. And here we see that the soil and weather sensors that can be deployed in these solutions will reduce waste and increase productivity in the farming community. So again, the business model around these applications essentially is self-funding and can drive that growth to massive levels. We've even seen this approach used in livestock. So the first photo that you see at the top there is an example of a program we did with LB Logics that will monitor silos and can tell you what the levels are in silos of any solids or semi-solids, and use the smart sensors to then be able to notify the owners of those assets when they've reached certain thresholds. The next photo down is another project that we worked on with Horseware Ireland called the HorsePal Edge. And that essentially is a fitness monitor for horses. It creates connected horses through the blanket that they're wearing and allows you to monitor health, activity, behavior, and the environment. So this gives you another example of very high volumes that could be achieved if it extends to livestock. Transportation is probably the one that's got most familiar to everybody here who's listening. And there are many different applications, from autonomous driving to micromobility to robotics to trucking. The thing that I'll point out is that we see precision locationing as being important in this market, and also vision AI systems, especially, for example, in the trucking industry, where there's more monitoring going on sleep patterns and that sort of thing if people are driving. So if we go on then to the next slide here, you might ask yourself, what happened to the bold predictions about connected devices? 10 years ago, there were predictions that there could be as many as 50 billion connected devices by 2020. And we haven't achieved that level at this point in time. But we're starting to see now that the pieces of the puzzle are coming together to enable this massive IoT phenomenon to take hold. The challenges on this slide are represented by the solutions that are starting to come together now. The first among those being the networks themselves. So now we have low power WAN options like Cat-M1 and NB-IoT that are available, and they're growing quickly. According to GSMA, there are 142 mobile IoT networks that are active now. In the next bubble there, you see the influence of the IC vendors around the world. The machine learning and AI capability that they've been bringing to market is becoming lower cost and lower power. It is more scalable as a result. And it enables innovation and integration to take place and to really support this massive deployment. Next, we see that there are working groups that are coming together and standards that are coming together. I've listed a few here that are focused on security because that's an example where the solutions have been highly fragmented over the years, but are now starting to crystallize. So you'll see standards like UL 2900 and ISO 27001 and working groups like OWASP that are enabling us to create interoperable solutions and complete solutions that deliver security. The same thing is happening with regulation. Vertical markets are key to deployment on a massive level, and many of the vertical markets have very strict requirements that are needed in order to certify devices and to keep people safe and healthy. And the standards that go along with IoT are now starting to emerge as well. And then finally, you'll see the power management. That's really a combination of many different technologies: battery technology, IC technology, low power, wide area networks, all coming together to extend the life of IoT solutions. So moving on to the next slide, we want to close by saying that we see this capability, really moving to the edge. Massive IoT will be supported by edge solutions and edge computing that maximizes efficiency, improves performance, and improves security by minimizing the amount of information that needs to be passed back and forth. So we think that these solutions will be far faster, smarter, and more secure. So let me close then and pass it back to Ryan.
Thanks, Dennis. It's always great to share relevant real-life applications and insights into kind of some of the biggest contributors to growth that we've seen and are hopefully hope that we will see kind of in the coming months and years. All very important stuff. All right, Jeff, you're up next. Look forward to hearing your take.
All right, thank you, Ryan. So, I think the key to massive IoT is obviously that, the predictions, as Dennis was talking about, of 50 billion, we're showing now 41 billion. And from our perspective, being a module platform and services provider, that this is starting to tick up, and we are actually connecting, many, many devices on a regular basis. And one of the things that's making that happen, as mentioned by both Henrik and Dennis, is the move towards the NB-IoT LTE-M evolutionary parts of the network, where we're moving from things that have been out there in the field and a lot of these verticals that Dennis was going over from a 3G perspective, even going back clear to 2G. But there were so many issues around power management and the ability to scale that kind of held things back. So with low power wide area network technologies of CAD-M and NB-IoT, not only is the component pricing that helps bring down the cost of the overall hardware part of the solution, you're also seeing better power management, better interaction with the networks, and the ability to truly leverage the cellular capabilities that are enabled in the space that we now call low power wide area networks. And of course, that's now being hyped around integrating into the future with 5G. But we can't lose track of the fact that, as noted by the previous speakers, that there's a lot of different RF technologies, and not everything is going to be solved by cellular. There's going to be times where, especially at the edge, you may have other technologies ranging in the different short ranges like Wi-Fi, BLE, Zigbee, Z-Wave, 900 megahertz, that are all going to be driving a collection of all those massive IoT endpoints back to a gateway or a router or a modem. And it's the ability to do more edge computing and all those different layers as it comes back through the solution stack and back into the application layer that's going to be key. And so what 5G is going to enable over the long haul is kind of the continued bifurcation of the cellular networks, where you're going to have dedicated backhaul and resources to the 5G that'll enable the low power wide area network traffic to be separate and to be utilized in a way that it was intended. So the networks are getting fine-tuned as the standards and technology continue to improve to enable the feature sets that are specific to the use case. So you may have an IoT solution that's got really high bandwidth requirements, where 5G, especially when we get into millimeter wave, will be very important. But there'll be a long road ahead of us with LTE, CAD-M, and NB-IoT support for those products and solutions that only need low power, low data throughput, and don't need the full capability of 5G. But that ability for those environments to work together in a network is where we're headed. And it's an evolutionary process. And when you look at applications that maybe struggled to have a business case back in 2G, and 3G opened that door a little further, LTE moved it along, and now with CAD-M and NB-IoT, it's really starting to take off. And I think some of the expectations of the billions of devices connected really become enabled as all this ecosystem comes together. And globally, more and more OEMs has definitely grown, and the capabilities across the world are there now, where it's not just the United States or Europe, right? It's a much broader footprint. So there's a bigger market opportunity for those who are trying to provide solutions into those specific verticals. And I think it's also important to note that it's going to be the growth engine for cellular, but it's also a growth engine for the hybrid model, in the sense that the more endpoints out there using either low-powered wide area network technologies or short-range RF technologies, and they all have to be aggregated and brought back to the core. So there's an opportunity for all the different capabilities of RF together with the different application layers and platform supports to all be bridged together to create the different business models that are enabled for either cost reduction, value-added services, or increased overall capabilities that make your end customers' experience much better. So one example is in the whole home automation security space, where you're seeing a lot of very big brands pushing solutions and bringing together various technologies to put in gateways that enable, smart lighting and security and other home automation capabilities that all can be managed remotely through a cellular connection. So you get that combination of the short range and the cellular that make a blended hybrid solution to really bring that concept of home security, smart home into that automation space that also gives the end user capabilities because they now have access to data they've never had before. So I think to Hendrik's earlier comment, there really is a potential for everything to be connected, and the value prop really comes down to whether it's a cost reduction, an improved customer experience. In the case of healthcare, it can be, better outcome, outpatient management, better personal experience, better doctor-patient relationships. I mean, the examples just go on and on. So I think we're really starting to hit the stride with the convergence of all these different technologies, and especially with cellular being able to be kind of a global technology that's enabling all this. So I'll close there and pass it back to you, Ryan. Thank you.
Thanks, Jeff. Yeah, it's clear that massive IoT applications and LPWAN definitely go hand in hand. It's something that we and myself talk about a lot on our podcast. So I definitely agree with a lot of the points and the value of LPWAN and what it can bring to the industry. So that's great stuff. Thanks again. All right, Andrew, over to you. I'm going to hand it over to you before we move into some question and answers.
Awesome. Thanks so much, Ryan. I really appreciate it. It's really cool to see all of the technologies kind of coming together and converging. But one thing I do want to kind of echo that I think a lot of my fellow panelists have touched on is that IoT is complex. There's a lot of different variables at play. And so developing IoT solutions is challenging. And so at Digi, what we see is many companies that are developing IoT solutions aren't typically high-tech companies. So an example would be a light bulb company adding connectivity to their light bulbs, or a lawnmower company maybe adding wireless connectivity for diagnostic purposes. And these companies that typically aren't high-tech companies are getting into spaces where they don't necessarily have expertise, such as the spaces like cloud infrastructure or writing firmware or handling certifications. And the challenge is that the customers are that these companies don't know what they don't know. And in a recent Cisco IoT survey, found that 60% of companies substantially underestimate the complexity of building an IoT service, and 75% of self-initiated IoT projects were considered a failure, which is kind of mind-blowing to think of. So I'm going to walk you through the three challenges that we see to IoT adoption, so you don't underestimate the complexity of IoT products. So the first challenge we see is reliable and managed connectivity. Even if it's not a critical application like a medical device keeping a heart beating, having reliable connectivity is paramount. And so the first challenge is reliable connectivity over multiple geographies. And that comes down to a lot of complexities with certifications and regulatory requirements that vary greatly between different regions. The second challenge we see is consistent technology in different regions. An example there would be maybe a region that in some parts has good LTE coverage, but in other parts only has 3G or 2G coverage. So making sure that when rolling out and having reliable connectivity, you need to address all of the different technology kind of diverse needs. The second challenge we see to reliable and managed connectivity is robust application with software, with exception handling and diagnostics. So it's really easy to build a proof of concept, but it's difficult to create an application that can kind of handle the complexities of deployment, handling things such as a network retry when you get booted off the network, or maybe incorporating health metrics to ensure that the device can proactively let you know when something's going on in the network, or air logging to help you debug an issue in the network. And so the third and final issue that we see is device management. So wireless technology requires tender, loving care. You can't set it and forget it. And so to handle the maintenance, you need to have proper device management to handle things such as firmware updates or health metrics, or even to monitor the connectivity status of the network that you have deployed. So the second challenge we see is with IoT security. And so everyone knows that security is important, and everyone's heard the nightmare horror stories about devices getting hacked. But many of the companies still don't have the internal expertise to implement proper security. And this is a challenge for products that are deployed for long periods of time, maybe 5 to 10 years of being deployed in the field. And as the software and regulatory environment is constantly changing, it causes an increased risk of security compliance. And so today you might be okay if you have secure products, but with shifting regulatory sands, both on the state, federal, and international levels, it can force large-scale investments. And two immediate examples that we've seen is a recent IoT security bill that was passed through the House, and then the California password law. These are just two recent examples, but we anticipate more to come. So to protect against that, you really need to ensure you have the right precautions made, make sure you have secure boot, proper encryption on your network. And something I think that is often underestimated is having full-time staff dedicated for monitoring the status of security, whether that's monitoring the landscape with the law and the regulatory landscape, or just understanding the landscape of different vulnerabilities that your network could be susceptible to. And third and finally, the third and final challenge I see to massive IoT scaling is that technology is consistently changing. And you can see this from your iPhones as they've moved generationally over time. Again, IoT devices are not set it and forget it. They will require maintenance over time. And so you need to be thinking about this before you deploy your IoT solution. And so that kind of goes into a few different areas. The first area is talking about new technology. There is always going to be new technology, so you need to make sure that you are able to handle the migration, have a future-proof solution, be able to handle the old to the new. And a prime example is going from old 2G and 3G networks to LTE, and then the future of 5G. Additionally, you need to think about the maintenance of the existing solutions that are already deployed. For this long lifespan technology, there's going to be maintenance that needs to go onto it. There needs to be considerations for what you're going to do when you need to update the software. What if a hardware component goes end of life? What are you going to do when a security vulnerability is found? And then additionally, as the regulatory sands keep shifting, you need to make sure that you're able to have this future-proof solution that can help prepare you for the future. And so I just want to talk quick about Digi. We've been trying to address all of these issues in our offering. We're a publicly traded company and have been in business for over 30 years, providing complete networking and IoT solutions. And we address reliable and managed connectivities through our firmware and software and our portfolio of XP modules and routers. We also pride ourselves in our proactive and built-in security. We have an expert team to help manage the shifting sands of the regulatory and the security landscape. And also we pride ourselves in our future-proof IoT connectivity portfolio to ensure that as technology changes, you'll be able to change with it. So hopefully those provide some actionable insights to some of the challenges we see to scalable IoT. So thanks, Ryan. Back to you.
Absolutely, yes. Thank you, Andrew. So I will say that the complexity of IoT is very important to note and understand. So appreciate you sharing those insights, because At the same time, companies need to understand that companies like Digi, Telit, Ericsson, Talglass, and others are here to help them on their IoT journey to avoid those common pitfalls that you were mentioning. This isn't like other technology developments that companies undertake. It's a very partner-centric and partner-driven ecosystem. So companies shouldn't shy away from working with companies like yours, and I think think they can do it themselves. So it's very important to kind of understand that in order for us to reach those expectations that we're all kind of in this industry to hopefully achieve. So thanks again for sharing those insights, and thanks to all the panelists for all their presentations here today. So let's go ahead and move right into some questions for discussions, and I want to pose the first one over to Henrik. How do we get to massive IoT market, or how do we get the massive IoT market to grow?
So it's a complex question. I'll divide it into three parts. One is we need to jointly in the industry remove barriers. Andrew talked about certifications, where IoT is kind of in the trisection of telco regulation, the industry-specific regulation where the equipment will be operating, and local and global regulation. So anything we can do in terms of certification, testing that makes it easier for enterprises to enter. I think that's the one. Number two is hook arm in arm with partners, right? Make sure that the enterprises sees our logos and understand that we all work together to make this happen, and then share success. We need to communicate because I see so many cool things that are being built that nobody knows about. We need to share the success and show that it's possible. The more that it's possible, the more money that will flow into IoT to build it. And maybe we can do something about that failure rate of 75% and get that as low as possible, because I see so many successful projects and I see companies doing them over and over again and not failing 75%. So we've got to figure out what does it take to succeed. And I think a lot of it is collaboration.
Let me ask a quick follow-up before we transition to the next question. How much do you think cost plays into this? As far as, I've spoken to a lot of executives, and one of their approaches is trying to get cheap sensors and cheap connectivity kind of combined into a solution to lead to massive scale. So how does the cost factor into this, into the potential for growth?
They always want the cheapest things to do the most expensive demos. I think it's important to understand that we need to stay on the value that we create. I understand that we need, as soon as we get into competition, we need to keep the cost low. But if you buy quality, you cry once when you pay for it. If you buy cheap stuff, you cry every time. Just like Andrew pointed out, this is not fire and forget. This needs tender love and care over time. So with quality products, you will get quality device management. You will be able to update the firmware over the air, software over the air, and you'll get a lower cost over time. So here articulating the total cost of ownership over a, 5-10 years period of time is probably what we need to do in order to fight those. Let's get a 5 cent off the bill of material arguments.
I agree. Great. Anyone else have anything to add to that before we jump into the next question? All right, let's get into the next one. So Jeff, this one I'm gonna aim over to you. How do you see 5G addressing the massive IoT kind of movement in market? How is it kind of going to play a role? What is it going to enable, and just overall impact?
Sure. Well, I think initially over the next couple of years, most of the emphasis in the new 5G technology is going to be oriented around verticals that are very high bandwidth in nature. So high power millimeter wave, low power millimeter wave, and sub-6 will all play a little different role. So in the IoT space, anywhere where you're doing massive data collection for endpoints that need to have some kind of aggregation, that's the role 5G will play. But as the carriers continue to invest in 5G and leverage different newly acquired spectrum, they will also continue to support the LTE functionality that we talked about in Cat-M and NB-IoT to leverage that part of the network separately so that you don't have the historical shared pipe issue, and you're going to have much more focused feature functionality to the use case. So if you have a large, massive number of endpoints NB-IoT or CAD-M may be the solution if you're doing a one-to-one type of scenario. But if you're doing some kind of aggregation point, then you can see 5G's capabilities start to play. And then over time, these standards will continue to merge together. A lot of people don't know that the 5G networks will continue to use for a long time the LTE backhaul that's already in place. But as 5G grows, that'll continue to have the new standards and features released that are planned over the next several years that'll just keep adding to what's already there today, making it easier and easier because the standards will be more integrated. So it's a continuous evolutionary process, and I think to a lot of the comments made already, that's why this is so complex, why you have to have a strategic partnership that is engaged across the ecosystem and can help you decide whether to make an investment in 5G today or plan on it in the future, and how that dovetails into the low power wide area network technologies and ultimately integrates with all the other RF that's out there that's going to help all these endpoints collect the data.
That's great. Yeah, we've talked a lot about connectivity today. One other area of IoT, which I think is, or I guess connected, that I think is worth mentioning, it kind of leads into our next question here, is AI and ML. So Dennis, I wanted to pose this question to you: is within the massive IoT segment, what are the emerging trends that you're seeing across ML and AI capabilities?
Thanks, Ryan. I think we're seeing nothing short of a revolution in technology that's based on machine learning and AI capabilities. And the base technologies have now been put in place, and they're being improved at a very rapid rate. So different architectures for neural networks have been explored and refined over time and are getting more and more capable. And you have now pre-trained models that can be brought to bear in different applications and can speed the time to market. So the massive complexity in this field can be reduced by leveraging past learning. And at the same time, we're seeing the other things that we had talked about previously support these trends. That edge processing is becoming lower cost and more power efficient, and is delivering more MIPS. So it's smarter than it used to be. The key trends that I would add to that we're seeing are around location technologies and in particular camera integration. So we see now that AI is enabling vision systems to be very intelligent. They're always on. They can be scanning the landscape. They can recognize text and do optical character recognition. They can, with stereo cameras, can also detect depth. So they have depth perception. These systems are becoming very capable and can really enable a whole range of new applications.
That's great. Yeah, I'm curious, as as we develop all these new applications and new industries, combining all these different technologies, there's always a concern about security, which kind of ties into our next question that I want to send over to Andrew. How will IoT security, or how will the IoT security landscape change in the coming years in general, and then also just kind of due to government regulations, which is something I know that was mentioned earlier as something that needs to be addressed in order for massive IoT to be achieved?
Yeah, you bet. I mean, I think it's one of the biggest questions, and it can easily be overlooked. But I think it's no doubt that more vulnerabilities will be found over time. And they will be exploited. So there needs to be ways to be able to fight against that and patch it. And what I'm really interested in is how government regulation is going to impact that, because I think if you look historically, the government has kind of batted an eye towards tech. I think partially due to the complexity of it, which we've all highlighted today during our presentations. But I think there is going to be a shift where there's going to be kind of a learning curve. And I think that all of the different governments, whether it's regional, countrywide, or internationally, are going to play a closer eye on any devices that have data, and especially like data like health information, which is very sensitive information. And I think that there's just going to be more and more legislation as governments kind of come up to speed with technology over time. So I think, you can expect that there are going to be more regulations to ensure that any sort of IoT solution sold or deployed is the most robust solution possible. So I think, as Henrik was talking about, you need to make sure you have a quality product, and you might have the pain up front of the cost, but doing it right and ensuring you have a really well secured product that is maybe over secured will save you your total cost of ownership over time. So I think the truth of the matter is there's only going to be more regulation to come, so make sure you're ready for it.
Mm-hmm. Yeah, always interesting when governments get involved in these kinds of things on the regulation side. So just being aware and making sure you're taking this into account before you get started on your IoT journey, I think is very important. So that's great. The next question we have, I wanted to pose over to Dennis. So we talked a lot about connectivity throughout this conversation today. So how would you, I guess, if you were talking to somebody, how would you kind of explain to them how they would pick Cat-M versus NB-IoT as a standard for a specific application? Like what would go into making that decision?
Thank you. I'm going to harken back a few moments ago to Jeff's slide, because that was such a stark contrast in what you saw there for deployment of networks. So he was showing that Cat-M1 is a dominant deployment in the Americas, and that NB-IoT was dominant in Asia. So availability of a solution might well drive your decision, depending on whether you have a local deployment in mind or a worldwide one. But then let's pop up a level also and assume that you really have a product that you want to deploy on a worldwide basis. Then we see really 2 3GPP standards here that can be used for a variety of applications. For NB-IoT, we tend to see applications like utility meters and sensors. They're lower complexity devices, and they require or can manage with lower bandwidth and lower data rates in general. For the Cat-M1, we tend to see a little bit higher complexity devices, connected vehicles and trackers, or wearables, or even alarm panels, where there is a higher bandwidth that's available, higher data rates are available, and other features like low latency or even positioning capabilities. And there's one other that Cat-M1 can also support voice calls and is more attuned to mobility. So those features tend to drive the selection process.
That's great. Yeah, I'm sure that's kind of the same process you got to go through no matter what type of connectivity you're going to be using for an application, which is something to be very considerate of going into the planning stages, because that kind of plays into contributing to the cost and then obviously the growth and the scale and potential for application to be successful, so we don't hit that 75% of applications, not making it through pilot stage. So kind of staying on the same topic of connectivity, Jeff, I want to ask you, what certification requirements are there when it comes to cellular versus short-range connectivity?
This is the one question that I find, especially for someone that's never done a cellular design before, to be the most scary. There are certification requirements for all RFs, especially with government regulatory bodies like the FCC. But in cellular, there's a lot of added layers, primarily driven by the MNOs, in the sense that they are out there to protect the technology that they're offering. And so they have very rigid requirements to be able to put your end device onto their network. So you typically have to get your regulatory certifications for your end product. Then you move to the carrier certifications, which sometimes can be a third-party lab, or it can be the carrier themselves. And every country is unique to a large degree. So you have to really understand each of the carrier requirements. Sometimes it can be just leveraging a third party's testing results. Others you have to get like PTCRB here in North America, and then move on to the end carrier certification. Most of it's focused on the impact potential on the network, both from an RF perspective, so making sure RF propagation is correct, making sure that you're not interfering with power output and things like that, but also the ability to interact with the back end of the system. So how does your SIM card interact with the billing and operations platforms? And how does your end device deal with situations where you might have lower than best quality connectivity, and so you have a lot of retries? It's all about managing their most precious resource, being spectrum, and making sure that everybody that's using it is using it as designed. Now, there is a subtle difference coming for a lot of folks that may not know this yet, but in 5G, especially for high power millimeter wave, the antennas are active antennas. And so the FCC has determined that not only do you have to have the cellular certification for sub-6, but in the high power millimeter wave, the actual end device at the system level has to be certified. So that's a nuance and change. So when you look at CAD-M NB-IoT, certifications tend to be much less complex, a little faster. The theory is a little less expensive because you can get through the testing faster. And then as you move up the LTE category scales to high, LTE high CAT, like a CAT 18, where you've got the complications around carrier aggregation and testing your end device across a moving target, so to speak. Then you move to 5G, where it's even getting more complex. So having a trusted partner or leveraging a third-party engineering firm to help you through that, especially if you've never done it before, is highly recommended. And there's a lot of partners in this ecosystem, some on this call, that can do that. So we really feel that the more you can do your homework up front, the better off you're going to be on your cost of actual certification. So cellular is a different animal than short range, and it's definitely something you have to factor into your business model and development costs.
Thanks, Jeff. Yeah, as I was listening to your answer, I was actually thinking to myself something that you kind of mentioned there at the end, which is the importance of partnerships when it comes to choosing a connectivity option. It's the intricate details that each piece of connectivity has and how it plays into specific applications and use cases is something that partners can definitely play a huge supporting role in helping a company decide on the right connectivity for their application, which obviously that translates and expands into all the components of an IoT solution. So the emphasis of partnerships is very well taken. But it does look like we're actually out of time for today. So it is clear, hopefully it is clear from this conversation, that massive IoT promises huge new developments in connectivity for all sorts of things around the world, and we could not be more excited about that. But other than that, I just want to wrap up by thanking all of our panelists for taking time out of their day to share their expertise and insights. It was truly appreciated. Also want to thank our sponsor, Telit. And finally, I want to extend another big thank you out to all of you who joined us today. We hope you found a lot of value in this, and we appreciate your time.